I do more rational exponent and radical practice today, guys. If you had any questions on the homework, we would have just finished going over those. So let's pick up where we left off. We're not going to do any rewriting today from one form to the other form. We're more so just going to focus on let's evaluate these. Okay, let's try to simplify them down. So we're going to dive right in. We're going to do 5 more like yesterday, and then I will show you how to do this on the calculator. So first problem, 8 to the 4 thirds plus 16 to the 3/4. As of right now, you cannot add these. They would not be considered like terms because of the exponents. So we're going to do each individually, and then we can add them together. So first term, we're going to take the cube root of 8. Hopefully you've started to study that chart a little bit or got some practice with last night's homework. So the cube root of 8 is 2, because 2 times 2 times 2 is 8, which will be to the 4th power still. And then the 16, I'm taking the 4th root of 16, which is also 2, to the 3rd power. Still can't add them even though the bases are the same, and that's because the exponents are different. So I have to do them out. 2 to the 4th is 16, plus 2 to the 3rd is 8, to get a final answer of 24. You got to take it all the way down so you got a single number for each. The next two, we're going to do a little bit of a comparison versus focusing on even versus an odd root when the base is negative. Okay, so 2 and 3 I'm going to write up here at the same time, and we're going to compare them. Negative 16 to the 5/2 and negative 64 to the 4/3. So in number 2, we have an even root of a negative base of a negative 16, and in number 3, we have an odd root, cube root of negative 64. So if you think back to the quadratic unit, when we tried to square root or take an even root of a negative, that's an imaginary answer. You can't get a real solution. So with number 2, because it's an even root of a negative base, there is no real solution. We can't get a value right now. And we're not going to work with I or anything like we did with quadratics at this point. So square root of an even root of a negative base, no solution at this point. Whereas in number 3, when you take an odd root of a negative base, you can do that. The answer will just be negative. So if you look at your chart, the cube root of positive 64 would be 4, but because we're cube rooting negative 64, it's going to be negative 4. And that's because negative 4 times negative 4 times negative 4 is negative 64. An odd amount of negatives stays negative. I'm keeping it in parentheses because it's negative and it still has to be raised to the 4th power. And once you raise the negative number to the even power, not an even root, but an even power, my answer will turn positive. So negative 4 to the 4th power is positive 256. So odd roots you can do, the answer is just negative. Even roots, you can't. Next one, and then we're going to talk about the difference with number 4 compared to number 2 as well. Okay. Now with number 4, I just finished saying that you can't take the even root of a negative base. And if you look here, okay, I have an even root, 4th root is even, and I have a negative base. But there is one big difference between number 2 and number 4, and that's the use of parentheses. So right now, when you're taking the 4th root, you're only taking the 4th root of 81, not negative 81, because it's not held together with parentheses. You could think of this like negative 1 times 81 to the 3/4 and pull out that negative separately. So parentheses usage is very important in distinguishing when you can and can't do something. So for this example, I can take the 4th root of 81. The 4th root of 81, check on your charts, hit pause, see if you get the same answer as me. 4th root of 81 is going to be 3. Okay, that negative is just going to come down, and then it's 3 to the third. I'm going to keep going with this before I start with the other half of the problem. When I cube the 3, I'm going to get 27, which is still being multiplied by that negative, so I will get negative 27 over here on the left. Don't forget about that, because that's not the final answer, but we'll use that in a minute. Now we're going to work through the right side of the problem. When you have a fraction with no addition or subtraction, you can distribute. So I'm going to distribute this to get 1 to the negative 2/5 over 243 to the negative 2/5. We're taking the 5th root of both. So the 5th root of 1 is 1. Any root of 1 is 1. To the negative 2nd. And then the 5th root of 243 is 3. To the negative 2nd. We're going to flip it. And we're going to get 9 over 1. And 9 over 1 is just 9. So the answer to the second half is a positive 9. So over here I'll have negative 27 plus 9, which will give me a final answer of negative 18. One last example before I show you how to do some of these in the calculator. So for number 5, we're going to have negative 8 times the cube root of 343 to the second power. So that negative 8 just means you're going to do the root out like normal and then multiply by negative 8 at the end. So this will become negative 8 times cube root of 343. It's going to be 7 squared. This will become negative 8 times 49. And now I'm going to do it on the calculator real quick. Negative 8 times 49 is going to be negative 392. That's the last of the evaluating examples. Let's move to the calculator. Okay, while that opens up, let me write down the example. Okay, so we're going to evaluate using the calculator. Let's do 2 of these. So the first one we're going to do is the 5th root of 68. I think it'll be easier and there's less chance for you to make a mistake if you always type them in the calculator in rational exponent notation. That's the first thing I'm going to do, is rewrite this as a rational exponent. So this will become 68 to the 1/5. And that's what we're going to type into the calculator. You do need at least a scientific calculator to be able to do this. You won't be able to do it on just a basic 4 functioning. You need something with a little caret key. So we're going to type in 68, and then the caret key, which is above the division symbol, to show that we're raising it up. If you have an older TI-83, then you'll actually see the little caret on your screen. And then we're raising it to the 1/5, so putting that in parentheses, especially important if you have one of the older TI graphing calculators. Anytime you're typing a fraction, it should be in parentheses. Then I'm just going to hit enter, and we'll round that to the thousandths place. So 2.325. Go out to the thousandths place. 3.235. We definitely couldn't do an example like this using the charts, because if you look at the charts, the 5th root of 68 is not on there. Okay, it's not a perfect value. It is a decimal answer. Okay, even if I gave you something like, and we're not going to do this one, but say like 16 to the 2/5. That would also be a decimal, even though 16 is on our chart. It's not on our chart under the 5th root column. So the 5th root of 16 is a decimal. The 4th root of 16 is a whole number. So it really just depends on the type of root. But we're not actually going to do that problem. And the next one, the last one, will be the 4th root of 5 to the negative 3rd. So we're going to rewrite that in rational exponent notation to get 5 to the negative 3/4. That's what's going to go in our calculator. Even though it's a negative exponent, we're not going to work with the properties by moving it to the denominator. We're going to type it as we see it. So 5 raised to the parentheses, negative 3 divided by 4, close the parentheses, and we're going to get 0.2999. I think I messed up on that last one. Sorry, guys, when I copied the answer. The last one was 2.325, and I totally did not write that. 2.325. I got my 2's and my 3's mixed up. And this one was, again, 0.299. Sorry. All right. So that's pretty much it to use in the calculator. Sometimes we have to use that in order to do the root because it's not a perfect nth value. The remainder of class, we're going to start with some other examples that are not necessarily on our charts, but I'm still going to ask you to try to simplify them down. These problems can be a little challenging because there's not just one set of directions that I could give you that you would use for all problems. Every problem is kind of unique and might use a different strategy. So here are some strategies. Okay, so let's, how do I want to label this here? I guess some simplifying strategies. Now these are not strategies used for like the ones we just did. If it's a perfect root, do it, evaluate it from using your chart. But these are some other types of strategies. Okay, first one, rewrite the problem as a low base. What I mean by that is if I gave you 9 to the 3/4. Well, 9's on my chart, but not for a fourth root. So what I would expect you to do to simplify a problem like this is I can rewrite 9 as a lower base, as a different number raised to a power. And that would be 3 to the second. 9 is the same as 3 squared. But I still have the 3/4 exponent, so it would be 3 squared to the 3/4, which I can then use my power to a power rule and multiply. Keep in mind, this is really like 2 over 1. So I'll get 3 to the 6/4, and I can simplify that fraction to get 3 to the 3/2. Now, I still can't actually get a final value here. Like if I tried to square root 3, that would be a decimal. And for simplifying, we wouldn't use the calculators. We would just leave it in this form. So I know it doesn't really seem that way, but 3 to the 3/2 is considered more simplified than 9 to the 3/4. That's the low base strategy. Try to rewrite the base as a lower base, as a smaller base. And this is all really good just manipulation with number skills that we're practicing during this section to be able to transform and find equivalent notations of one to another. Another strategy is to look for same bases. Because then we could use the properties of exponents. Like if you're multiplying same bases, you'd be able to add the exponents together. Okay, so you can use some of those strategies. Another property that you could, or another strategy you can look for is look for the same root or power. Okay. When you have the same root or power, you can actually undistribute that power from everything, allowing you to do some additional math, and you'll see some examples of that tomorrow. And then 2 other tidbits that I'm going to write down. If you are adding or subtracting terms, they have to be the same base and the same root to be considered like terms. So that's important. If I ask you to add or subtract, to be like terms, they have to be the same base and the same root to be able to combine them. And the last strategy is to look for perfect factors, to try to break down in radical notation. This is something we did during our quadratic unit. So a quick example of that. When we had the square root of 24, we would break this down by looking for a perfect square that went into 24, which would be 4, and it goes in 6 times to get 2 radical 6. I can do that same idea, but with other roots. So if I changed it to the cube root of 24, instead of looking for perfect squares that go into 24, I'd be looking for perfect cubes. Now my perfect cubes are 1, 8, 27, 64, and already I'm way too big. So the only one that could go into 24 is 8. And it does. If it didn't, then you couldn't break this apart. So it'd break into the cube root of 8 times the cube root of 3. Now we chose 8 because it's a perfect cube. The cube root of 8 is 2. And the cube root of 3, despite what you might think is not 1, cube root of 3 is a decimal, so that has to stay inside. So you'd get 2 cube roots of 3. So we're going to start just a couple examples of these strategies, but more so they're going to be done tomorrow. So for all of these, we're going to do 2 today. We're going to go ahead and try to use some of these strategies to simplify down the expression. So 16 to the 2/3. First thing you should look is see if that's on your chart. Can you take the cube root of 16? Pause, look at your chart. Is that on there underneath the cube root column? No, it's not. Okay, so cube root of 16 is a decimal, but for simplifying, I don't want any decimal answers. I have to use another strategy. Typically, when it's just a single term like this, the strategy that you will most likely use is strategy number 1, which is to rewrite as a lower base, which we can here. 16 can definitely be written, and you want to write it as its lowest base possible, which in this case is going to be 2 raised to the 4th power. 16 is 2 to the 4th power, which will then be raised to the 2/3 still, because that can't go away. Power to a power rule, we're going to multiply and get 2 to the 8/3. Okay, we're going to leave it like that. There are some other strategies that say that you're not allowed to have an improper fraction. For our class purposes, I'll be okay if you guys leave it as an improper, although there are some times where pulling out whole units of 2 would be useful. But we can leave it like that. 2 to the 8/3 is our final answer. All right, last one for today. 125 to the 1/9 over 5 to the 1/4. So if I look at our list, okay, so keep in mind we have the low base, same root, adding and subtracting, and perfect factors. So these are not the same base. These are not the same root. We're not adding or subtracting. I could try to look for perfect nth factors, but this is actually, again, another low base problem. The denominator is already a low base. The numerator is not. So we can rewrite the numerator. Instead of 125, I'm going to write 5 cubed. That's still to the 1/9, and it's over 5 to the 1/4. Power to a power, I'm going to multiply. That's going to be 3/9, and 3/9 simplifies to a 1/3. The reason why that was useful is now I'm dividing same bases, so I can use my properties of exponents and subtract. So although they weren't the same base in the beginning, after I rewrote them as a lower base, now they are. So I can use those properties of exponents because I'm dividing same bases. So off to the side, I'm going to do 1/3 minus 1/4. You have to get common denominators for adding and subtracting. So I'm going to multiply the first fraction by 4, second fraction by 3. I will get 4/12 minus 3/12. which is 1/12. My final answer then, I take 5 to the 1/3 and divide it by 5 to the 1/4, I will get 5 to the 1/12. And that is it. So we will pick up tomorrow and definitely do a lot more of these. And they can be pretty challenging just because there's not one set strategy that always will work. Your homework tonight is just a couple quick questions on the same worksheet as last night, and it's just practicing doing the roots on the calculator. And then tomorrow's night's homework will be using these set of strategies, trying to do the low base or look for common bases or common roots, which we're practicing tomorrow. Bye, guys.